So one piece of notation that I forgot, component form of a vector, let's say vector v looks like this, 3, 5, right? Another way to write that is 3i plus 5j. Now these are two different ways of writing, two different types of notation. Don't confuse the two. That's what people always do. They just say, I'm not sure which one to use, so I'll just use both. Well, then it doesn't mean anything if you use both. Because this is saying, this first one says, this is a vector in standard form who ends at 3, 5, right? This one is actually saying that I is a vector and j is a vector, and I'm adding some vectors together, right? So I is a unit vector, meaning that it's 1 unit long in the positive x direction. So you could say that the magnitude of I is 1 and the direction of I is 0, couldn't you? Right? That's because it's in the positive x direction, right? So the direction spinning from the positive x axis is 0. J, likewise, has a magnitude of 1, but its direction is 90 degrees. In other words, it's pointing in the positive y direction. So you can see that this says I have 3 1-unit vectors in the x direction, and I have 5 1-unit vectors in the y direction. So if you add them all together, of course, you end up with the same place as this. Okay? It's just two different notations. They're both expressing the vector in component form. Okay? Yeah.
So you have two vectors going in opposite directions, but they're longer. The one that's shorter is faster.
Yep.
And just the difference between the two vectors.
Right. If they're going the exact opposite direction. Yeah. If they're not going the exact opposite direction, then it's not quite so simple. But yeah. Something else I was going to say. What was it? Oh. So if let's say that we have a vector whose initial point is at 3, 5, and its terminal point is 5, 8, let's say. Okay? So let's put it in the ij form. So I'm going to express this vector in something times I plus something times j. Does anyone have any idea how you could possibly do that?
Maybe just plug in 5 for I, or
No, that won't do it because 5 is not the. So remember, we want the x component. Robert, you have an idea? Yeah. So we want to subtract the initial point from the terminal point, right? Because that'll get it's component-wise, right? So this would be 5 minus 3, so that'd be 2i plus, and then 8 minus 5 is 3j. So notice what I've done there is I put in component form, which means it's not really telling me where it's at in the plane. It's just telling me the magnitude and direction of it, right? Or the components of it. So if I want to know actually where it is, I have to at least know the initial or terminal point, right? Because this is actually, the way I've written it is, it has a specific initial point, a specific terminal point, and so it's, I don't know if there's a reason it's there, but it's sitting somewhere in space, right? Or in 2D space. So when I write it like this, I'm really expressing it in kind of a generic form, as if this gets me ready to move it around wherever I want to, because I know the components now. If I know the components, then I know the magnitude and the direction, because as we just said, because we're all trigonometers, we can take it from component form and figure out the magnitude and direction, right? Okay, now, here's a question that I'm going to have you struggle with for a bit, or maybe you won't struggle. I want a unit vector. Oops. How do I put this section in? I want a unit vector call this V. I want a unit vector in the same direction as V. So remember what a unit vector is? It's a vector that has a magnitude of 1, right?
Mm-hmm.
So I want a unit vector in the same direction as vector V. And vector V is that one we just found. Yep, 2, 3. This vector right here, vector V. Right? So I'll give you some time to think about that. So once again, if we have the unit vector, we know it's 1. The magnitude is 1. The theta is the same theta as that theta right there, where this is vector V, right? And we know the components of vector V are 2, 3. So the magnitude, I don't care about vector V. I don't care about the magnitude is. What I want to know is the theta. So tangent of theta has to be equal to 3/2, right? So then I take inverse tangent of 3 divided by 2, and I get theta is equal to 56 degrees, 56.3 degrees. So therefore this would have the same. Yeah? So that would be one way to do it. Could we put this back in component form now? Well, of course, Odell. We're trigonometers. What are you talking about? What kind of question is that? You insult me by asking that question. So this thing is 1, and this angle is 56.3, and I want to know what that angle, that side is, and that side is, right? So it looks like we need a cosine and a sine, don't we? This is back to the unit circle, isn't it?
Yes.
Hey, we've come full circle. We're back at the beginning. What on earth? I should have known with the unit vector, unit circle, I knew it would come back around. It's almost as if he planned it. Okay, so I want to know what cosine of 56.3 is, right? And that would be 0.55i, yes? Then I want to take the sine of 56.3, and that would be 0.832j. So that would be my unit vector in component form. Okay? I don't like that method. It's too much work. Someone have another method? Actually, I like it. It's nice. But anyone have a different method? Think back to something I said earlier. When you multiply a vector by a scalar, what happens to the vector?
It makes it larger.
That's the unit vector in the same direction as V. Yeah. It changes the magnitude, but not the direction. So what would happen if you divided a vector by a number? It'd make it shorter, but it wouldn't change the direction, right? So if I'm looking for a vector in the same direction as V, but a magnitude of 1, couldn't I just take vector V and divide it by its magnitude? Because that would make it a magnitude of 1, wouldn't it?
Yes, Mr. Odell, it would.
So, I don't know if this is much less work, but so if we had the vector 2, 3, that's my V, right? So the magnitude of V is equal to the square root of 4 plus 9, which is the square root of 13, right? Just use the Pythagorean theorem there. So then the unit vector U would be 2 divided by the square root of 13, comma 3 divided by the square root of 13. And just so that we'll be thoroughly impressed, we'll take 2 divided by the square root of 13, and we'll find out that it's 0.554700. It's the same as that. And 3 divided by the square root of 13 is, lo and behold, 0.8320502.943. Same thing we got before. But we didn't even have to do the division. We could just leave it like that because we don't mind radicals in the basic. And if you wanted to do it completely full circle, you could find the angle of this, of the direction of this vector, and you'd find out that it's 56.3. Because it doesn't. Because dividing and multiplying by a number scalar does not change the direction of the vector. Okay.